Today we are doing binomial approximation to normal. Now, in the binomial distribution, data is discrete, right? Whereas in normal distribution, there is continuous data. So, in binomial approximation to normal, we're converting discrete data, we're representing discrete data in the form of continuous data, right? Now, when is this used? Now, for this you need to be strong in binomial distribution and normal distribution, so you can watch my videos on those as well. Now, for example, if we have 10 dice, right, and a success is getting a 6, so the probability for success will be 1 over 6 because there's only one 6, and the probability for failure is 5 over 6. Now, if we have to find the probability of there being more than 8 successes, right? So that would mean that there are 9 6s or there are 10 6s. So we'll use the formula for binomial distribution and find the probability for this. Now, for example, we had 100 dice. Again, success was the same, 6 on dice, and probability of success was 1 over 6. Probability for failure was 5 upon 6. But now we have to find the probability that there are more than 60 successes. So one way would obviously be probability of x equals 61 plus probability of x equals 62, and so on till the probability of x equals 100. But that will not be feasible, right? So this is where approximation of binomial to normal comes. Conditions for approximation of binomial to normal are that in the binomial expansion, in the binomial distribution, the expected value or the mean should be greater than 5, and expected value of this is the expected value of success, right? Basically the formula is NP is greater than 5. Similarly, NQ should also be greater than 5, right? So for example, over here we had probability as 1 over 6 and 5 over 6 and 100 dice. So 100 times 1 over 6 gives us 16.67, and then 100 times 5 over 6 gives 83.3. So over here we can apply approximation as the conditions are met. How do we apply approximation? So first we'll find the mean. The formula for mean is mean in binomial distribution is NP. So 100 times 1 over 6, this is equal to 16.7, right? This is the mean. Then we'll find the variance. The formula for variance is NPQ. So variance is 100 times 1 over 6 times 5 over 6. This is equal to 13.9. So this is my mean. This is the variance, sorry, not standard deviation. So now I have converted my binomial distribution to a normal distribution. So x now follows normal. The mean is 16.7 and the variance is 13.9. So we have binomial distribution now. Now one more concept that is included in approximation to normal is continuity correction. Now why do we have to perform continuity correction is because, as we did earlier, binomial distribution has discrete data whereas normal has continuous data, right? So if for the binomial distribution I made histograms. So they would be somewhat like this, right? Now this represents, for example, let's say 10, this represents 9, this represents 8, 11, 12, 7 and 13, right? So when I make the histogram, I'll join the midpoints of these for the curve, and this will be the normal curve, right? Now for example, I have to find probability of x greater than 10, or let's say x greater than 12. So this whole bar represents 12. So I have to find this area after that, right? So this was 12, this is 12.5. So when I convert this to a standard normal distribution, so what I'll do is that I'll take my x value as 12.5 instead of 12. Similarly, if for example we had this is the curve of the binomial that we've converted to a normal, the mean over here is, let's say, 50. You have to find the probability of x less than 48. So we'll have 48 somewhere over here, and it will have, originally it would have a bar like this, a histogram like this. So to find x less than 48, when I convert it to a standard normal distribution, I'll take x as 47.5, because I have to find less than 48, that means this region, right? And this value is 47.5. So I'll take 47.5 minus the mean upon the standard deviation. Question 11. It is known that on average 2 people in 5 in a certain country are overweight. A random sample of 400 people is chosen with a suitable approximation to find the probability that fewer than 165 people in the sample are overweight. So there is a binomial distribution first, in which the total number is 400. Probability of success is, over here success is being overweight. Yeah, so the probability for success is 2 upon 5, because 2 out of 5 people are overweight. So 2 upon 5, and failure is 3 upon 5, right? Now we have to find probability of x less than 165. If you try to do this through binomial distributions formula, it would be a lot of working, and that's not possible. So we'll have to approximate, and it's given in the question to use a suitable approximation. So we'll have to approximate. Now since over here it's given that use a suitable approximation, so you don't have to apply the conditions and see if it's applicable. We can directly do the working over here. So I'll first find the mean. Mean is n into p, so 400 times 2 upon 5, (160), and then I'll find the variance, which is 400 times 2 upon 5 times 3 upon 5, that is 96. So now x follows normal, 160 mean, and variance is 96. Mean is 160, and we have to find probability of x less than 165, right? Now this 165 is somewhere over here, let's assume. So there will be a bar over here like this. You have to find probability of less than 165, right? So we have to find this region. So probability of z less than, we'll take 164.5 because this point is 164.5. So 164.5 minus the mean upon the standard deviation, that is the root of the variance. So probability of z less than 6.991. So in the table you have to find 6.991. Made a mistake. 164.5 minus 160. Answer upon root 96. This is 0.459. Probability of z less than 0.4593. So 0.4 and then 0.45 and then 9. So 0.6736 and then there's 932. So first add 2 over here, 0.6738 and then add 30, so 0.6768. 0.6768. So this is equal to 0.6768, that is equal to 0.677. So that's your answer. This is question 20. The probability that New Year's Day is on a Saturday in a randomly chosen year is 1 upon 7. 15 years are chosen randomly, so n equals 15. Find the probability that at least 3 of these years have New Year's Day on a Saturday. So over here probability of success is 1 over 7 and probability of failure is 6 over 7, right? And in the first part we'll just use the binomial distribution to find the probability because it's easily possible to do this without approximation. So we have to find probability that x is greater than or equals to at least 3, right? So greater than or equals to 3. So this is equal to probability of x less than 3. Sorry, 1 minus probability of x less than 3. So 1 minus probability of x equals 0 minus probability of x equals 1 minus probability of x equals 2. So probability of x equals 0 is basically 1 upon 6 upon 7, power 15. Probability of x equals 1 is 15 times 6 upon 7 power 14 times 1 upon 7. Probability of x equals 2 is 15c2 times 6 upon 7 power 13 times 1 upon 7 power 2. This is equal to 0.365. This was the first part. Now in the second part they're saying 56 years are chosen randomly. Use suitable approximation. Again they're telling us to use the approximation. Find the probability that more than 7 of these years have New Year's Day on a Saturday, right? So they have told us to use an approximation. Now over here n equals 56, p is again 1 over 7 and q is 6 upon 7. So finding the mean, 56 times 1 upon 7, that is I believe 8. Then for the standard deviation it's 56 times 1 over 7 times 6 upon 7. That is 48 upon 7 equals to 6.86. So we've got x follows normal 8, 6.86. So mean is 8. Now what do we have to find? We have to find the probability that more than 7 of these years have New Year's Day on a Saturday. So we have to find the probability of x greater than 7. Now 7 will be somewhere over here. This is 7's bar. We have to find x greater than 7. This point will be 7.5. So when I'm standardizing it, I'll have z is greater than 7.5 minus 8 upon root of 6.86. So minus 0.5 upon root of 6.86. Probability of z greater than minus 0.191. Yeah. Now how do we find the probability of z greater than negative 0.191? This will be equal to 1 minus phi 0.191. Sorry, it won't be 1 minus, it will be phi of 0.191, right? This has been done in the binomial normal distribution video, so you can see it from there. So 0.191, 0.1, then 0.19 is 0.5753, and then plus 1, 0.5757. When a butternut squash seed is sown, the probability that it will germinate is 0.86. Probability of success is 0.86. A market gardener sows, so probability of failure is 0.14, right? A market gardener sows 250 seeds, n is 250. Uses suitable approximation to find the probability that more than 210 germinate. Again, over here it's given that we have to use an approximation. Finding the mean first. So n times p, 250 times 0.86, 215, and then the variance, so 250 times 0.86 times 0.14, 30.1. is the mean. Find the probability that more than 210 germinate. Will be somewhere over here, let's assume. So this will be the bar for 210. To find the probability of x greater than 210, right? So this region. This point will be 210.5, right? So when I am standardizing it, I'll have z greater than 210.5 minus 215 upon root of 30.1. This is less than 0.8202. So if I make the standard wala curve, this is 0. Obviously this will be towards the left. We have to find this region. Now this will be equal to phi of 0.8202 because of symmetry. So 0.8202, this is 0.8, this is 0.82, so 0.7939, then it was 0, so we'll stop over here. 0.7939 equals 0.7939, that is 0.7942 SF. I'm doing question 56. A triangular spinner has one red side, one blue side, and one green side. The red side is weighted so that the spinner is 4 times more likely to land on the red side than on the blue side. The green side is weighted so that the spinner is 3 times more likely to land on the green side than on the blue side. Okay, so I'm taking probability of blue side as x, then probability of red side landing on the red side is 4 times that, so 4x. and probability of landing on the green side is 3 times that of the blue side. So probability of green equals 3x. Now we know that total probability is, because these are exhaustive events, that is, these are the only possibilities, so the total probability should be 1. So x plus 4x plus 3x equals 1. So x equals 1 over 8. They're asking us to show the probability that the spinner lands on the blue side, so that is x, so it's equal to 1 over 8. We've proved it. Second part, the spinner is spun 3 times. Find the probability that it lands on a different colored side each time. So the spinner is spun 3 times, and every time it has to land on a different colored side. So the first time it lands on 1 over 8. First time it lands on blue, so 1 over 8. Then it lands on red, so 4 over 8. Then it lands on green, so 3 over 8. Right, and then there can be 3 factorial arrangements of this. So this will give us the probability as 9 upon 64. Also, why did we use 3 factorial over here? That is because in this case I've assumed that the first dice had blue, the second dice had red, the third dice had green. It's possible that the first has blue, second has green, third has red, or first is green, or first is red. So in that way there are 3 factorial possibilities, so we have to multiply by 3 factorial to find the total probability. Last part, the spinner is spun 136 times. Use a suitable approximation, it's given, use an approximation to find the probability that it lands on the blue side fewer than 20 times. So over here P will be 1 over 8 because blue is a success, Q will be 7 upon 8, right, and N equals 136. So I'll first approximate it to normal using finding the mean and the standard, the variance. Mean will be 136 times 1 over 8, that is 17, and variance will be 136 times 1 over 8 times 7 upon 8, that is 14.875. Now they're saying that find the probability that it lands on the blue side fewer than 20 times. So probability of x less than 20. Now what is x? X follows normal, and mean is 17, and variance is 14.875. So a rough graph, and then this is the mean, that is 17. You have to find probability of x less than 20. So 20 will be somewhere over here, right? This is the bar for 20, and you have to find less than 20, right? So this point will be 19.5. So we'll take z less than 19.5 minus 17 upon root of 14.875 to convert it to the standard normal distribution. So .648. This is equal to phi of 0.648. So phi of 0.648. This is 0.6. This is 0.64. And then we have to add 8. 26 is for 8, right? So we're adding 26 to this. First I'm adding 6. So this will become 0.7395, then add 20, so 0.7405, 0.7415 equals to 0.7415, that is 0.742, sorry, 4223 SF. First part done. For the second part, a random sample of 150 people in the UK is taken. Find the probability that more than 60 people are group A+. Okay, so in the first part they were saying that rhesus plus is taken, so only the positive ones were taken, but now there can be positive or negative. So probability of success will be getting a person of group A plus, so that means 8%, 8 upon 100, that is 0.08, and Q will be 0.92. N is 150. Now first approximating this, so mean will be 0.08 into 150, that is 12. Variance will be 0.08 times 150 times 0.92, 11.04. So x follows normal, 12, 11.04. You're saying find the probability that more than 60 people are group A plus. So more than 50 people are group A plus. On the second part, they're saying a random sample of 150 people in the UK is taken. Find the probability that more than 60 people are group A plus, right? So now first what they were doing was they were taking people from the rhesus positive, the positive groups, but now they're taking from all of them, positive plus negative. So the probability for success will be, there are 35% A plus, so 0.35, and then failure will be 0.65, right? N is given as 150. Now I'll approximate this, so mean will be 0.35 times 150, that is NP, so 52.5, and then variance will be 0.35 into 150 times 0.65, that is 34.125, right? So x follows normal, 52.5, 34.125. They're saying find the probability that more than 60 people are group A plus. So this is the curve, 52.5, and more than 60 are group A plus, right? So 60 will be somewhere here. More than 60 means more than 60.5. So probability of x greater than 60, probability of z greater than 60.5 minus the mean, that is 52.5, upon the deviation, which is root 34.125. So 60.5 minus 52.5 upon root 34.125. So z is greater than 1.369. 1.369, right? So if I draw a standard wala curve, so this is 0, this is 1.369, I have to find this region, right? So what I can do is I can find this region behind it and subtract that from 1. So I'll have 1 minus phi of 1.369. Phi of 1.369 we'll get from the table. So there is 1.3, 1.36, and then plus 9. 9 is 14. So first I'll add 4, 0.9135, and then add 10, 0.9145. So 1 minus 0.9145 is 0.0855. That's the second part's answer.